I'm going to show you how to measure the distance to a galaxy. The galaxy I'm going to use in this example is NGC 3198. It's in the constellation of Ursa Major. I'm using this particular galaxy because it has a well-defined spiral shape, it has a rotation profile that is available to us, and there are other methods of distance measure that have been used to this galaxy, so we can then tell by comparison how accurate we are.
Here we are at the DSS MAST site from the University of Strasbourg. We punch in NGC 3198 and press return. This is what the sky survey now looks like, and it has found coordinates and so forth for NGC 3198. We then select the HST Phase 2 survey and use these images which come from this survey. We then select the scale to be 10 minutes of arc, both height and width, so we have a nice square picture with 10 minutes of arc wide and 10 minutes of arc high. I select a GIF file format, press retrieve image, and the image of the galaxy then appears. And this is the image of NGC 3198 that I will reverse or invert the values of the pixels, so it's a negative image, and send it to the printer. Hello, here we are with our photograph reverse image of NGC 3198. Now, if we take across the major axis, it's the major axis here, right through the center. Take across the major axis. We look at the pixels on the major axis. We'd see that they would end up having, at the center, of course, greatest response, and we see that there are a section of points that have greater luminosity as we move outwardly, and that's where these spiral arms are crossing the major axis. Now, we can see there's one here. There's one here, there's one here, and one here. And looking at the central part, we then measure, and they should all be about the same. This is at 2.8 centimeters, or I'll put it right here, 2.8 centimeters. This one here. Gain 2.8. Yes. This one is also 2.8 centimeters, which is one of the properties of a spiral, is that these spiral arms will cross the major axis at regular intervals. Next thing we have to know is how wide this is. It says 20 centimeters across, so that is now 20 centimeters, which is equal to 10 minutes of arc. So this primarily is what we need in order to measure the distance to the galaxy from this particular photograph, and now all we need is a rotation profile of this particular galaxy. This is a graph of the rotation profile. This data comes from Begemann. This is the rotation profile of NGC 3198. And we're looking at a maximum velocity on the outer regions of the galaxy of approximately 152 kilometers per second. We now have some very simple calculations. We have measured 2.8 centimeters between each of these spiral arms across the major axis. We scale that by multiplying by 10 arc minute over every 20 centimeters. to get 1.4 arc minute. We now have 1.4 arc minutes. We have 152 kilometers per second of the speed of rotation, a maximum speed of rotation of the galaxy, times 1.4 arc minute to get a value of 212.8, which would be kilometer per second arc minute. We take this particular value, we have the magic number 3.12 times 10 cubed megaparsec. If it's parsecs, that'll be 10 to the 9th, but we're megaparsecs, so it's only 10 cubed, divided by 212.8. To give us the value 14.66 megaparsec, which we can round off to 14.7 megaparsec. Now, comparing this to other values, we have 14.7 megaparsec, which we have measured. Alternative, we have 14.5 megaparsec by Farrarese using Cepheids. Gildas used Cepheids as well to get 17 megaparsec. Both of these use Cepheids. Tully-Fisher measured 13.8 megaparsec, and Rout et al. Measured 15.3 megaparsec. We take the average of these four values, we end up with a value of 15.15 megaparsec, which is the average. Our value, 14.7, which we have just measured, is well within the ballpark and is very close to Farrarese and is quite close to what we have measured here.